Ladies and gentlemen, our program will now begin. Please welcome the CEO of the Churchill Club, Karen Tucker.
Hello, and thank you so much. Our program tonight here at the Churchill Club is called The New Faces of Manufacturing. We're privileged to welcome three distinguished speakers. Jason Blessing, CEO of Plex Systems. Rod Brooks, founder, chairman, and CTO of ReThink Robotics. And Mark Hatch, CEO and co-founder of TechShop. And here to lead them in conversation is Michael Chui, principal of McKinsey Global Institute. Welcome, and thank you all very, very much for being with us tonight. Thank you also to our member and sponsor, Plex Systems. We couldn't have done this without you, and we really appreciate it. Thank you. I also want to acknowledge our member, partner, and supporter, Airfoil Group, for your help in putting this program together. Airfoil team, you're the best. Thank you so much. A brief introduction to Churchill Club for our new guests in the audience. We are Silicon Valley's premier technology and business-related forum and have been convening unique Silicon Valley-style conversations since 1985. And what drives us every day is to encourage innovation, economic growth, and societal benefit. And we do this through the up to 40 programs that we present each year, where like minds can learn and connect with one another. And we are a member-supported nonprofit organization, and we welcome you to join, participate, and get closer to the extraordinary conversations that we are igniting on a regular basis. Our next program is next week on October 24 in Santa Clara, as we discuss what can we learn from Amazon, with Brad Stone from Bloomberg Businessweek and 4 former Amazon executives. This discussion is presented as we approach Amazon's 20th anniversary. We also invite you to visit our YouTube channel, where you can view recordings of just about all of our past events. The most recent ones include 2 of our greatest programs of the year. The first is a day-long conference called Changing the Game. This year's theme was power, and you can watch and hear various ideas about power, as well as 6 workshops on topics such as voice, communication, fitness, meditation. And the second program I mentioned is the Churchills. That is an event that highlights excellence in leadership, innovation, collaboration, and social benefit in order to inspire us. And you can watch and listen to the extraordinary people and teams such as Mark Benioff and the Mars rover team. And this is available to you free of charge. If you're tweeting tonight, please use the hashtag Churchill Club, and you will find other Twitter codes in your printed program. Our moderator, Michael Chui, is a principal and senior fellow of the McKinsey Global Institute, which is the economic and business research arm or think tank of McKinsey & Co. And there he directs research on the impact of a wide array of long-term technology trends in business and the economy. And it is always a great privilege to welcome him back to our stage. Please give your warmest welcome to Michael Chui.
Thanks, Karen. Thanks to the Churchill Club, and thanks for all of you to spend some of your evening with us, and of course to our distinguished panel. As Karen mentioned, we're joined by Jason Blessing, who's the CEO of Plex Systems, has had a variety of executive roles at a number of different high-tech companies, including Oracle, Taleo, PeopleSoft, and also Pricewaterhouse, and is a graduate of University of Michigan. Rod Brooks, to your right, is the founder and chairman and CTO of ReThink Robotics, was also the co-founder, CTO, and a board member at iRobot, was a professor of robotics at MIT and director of the Computer Science and AI Laboratory there, and has a PhD from Stanford and graduated from Flinders. Other stuff, member of the U.S. Academy of Engineering, AAAS, AAAI, et cetera, an alphabet soup of honors, which are well deserved. And finally, Mark Hatch, who is the CEO and co-founder of TechShop, has had innovation roles at a variety of other companies, including Avery Dennison, Kinko's, and HealthNet, and also is an author of the book, The Maker Movement Manifesto, Rules for Innovation in the New World of Crafters, Hackers, and Tinkerers. So with that, let me just, first of all, it's exciting that we have, almost a couple hundred people in this room, and more that'll be on the web, here to talk about manufacturing, because we're in a place where people talk about software and people talk about cloud, which I think is important too. But the fact that there are people who are excited about manufacturing, I think is really important and exciting. Just a few facts just to get us started about manufacturing. First of all, it is still growing. I mean, despite all the things that have been happening in the economy and in the global economy, in the advanced economies, the developed economies, manufacturing is still growing value add at 2.7% annually, and in developing countries at over 7%. So it's still continuing to grow. It accounts for 16% of global GDP and 14% of global employment. And in fact, there's an interesting thing that happens. We've looked at countries as they develop. And in fact, early on in a country's development, the percentage of manufacturing is quite low. It actually peaks around 20 to 35%, and then actually decreases as services come to the fore. But that doesn't mean there's less manufacturing going on. That actually means that manufacturing oftentimes becomes much more productive. In fact, manufacturing accounts for 90% of business R&D, and about 70% of exports are manufactured goods. In the US, manufacturing's share of productivity growth is twice its share of output or employment. And that innovation has driven deflationary, in a good way, effects in manufactured goods. So the cost of US durable consumer goods, such as appliances and automobiles, has only risen at 1/10 of the overall CPI since the 1980s. So again, manufacturers have been innovating in ways that perhaps we don't think about all that often. So with that in mind, why don't we turn to our esteemed panel. Mark, I'll start with you. I'd love to hear from you. I mean, we talked a little bit before about what factors are changing manufacturing, particularly in this country. What are the things that are making a difference? So, is it democratization? Are there things about energy? What's going on?
Yeah, so, counterintuitively, I'll start with energy because I care deeply about democratization. But when I talk to our partners, Ford, General Electric, and others, it turns out that the United States now has a significant material competitive advantage in energy. And so it gives us an opportunity to be able to move manufacturing onshore and offset some of the labor costs directly as a direct opportunity. And so the fracking that's going on, regardless of where you fall on that, the reality is, as a result, we have a substantial, continuing competitive advantage on the manufacturing side as far as energy. So any component that has a large energy piece of it is going to be moving back to the United States. And so you see global competitors, whether it's Honda or Kairosei or Caterpillar or Apple, they're moving back to the United States. Now what we do with that is obviously an opportunity, and that's where I love what TechShop is doing, obviously, where we're democratizing access to the tools of the Industrial Revolution, enabling everybody to participate in the creative economy.
For people who don't know, what happens in TechShop?
So TechShop is a membership-based, do-it-yourself fabrication studio. Membership-based means we're like a 24-hour fitness. $125 a month gives you access to the tools of the Industrial Revolution. This is a 4 orders of magnitude reduction in the cost. Let me repeat that. 4 orders of magnitude. What used to cost you $5 to $10 million to set up, you now have access to at one of our facilities for $125. Importantly, what's happening is that the software tools and the computer tools that manage those tools make it easy, powerful, and cheap. And so we now are teaching people how to use the tools of the Industrial Revolution in 2 or 3 days. They come in, they create their new product, and they launch sometimes small little companies and sometimes not so small companies. So Square, the peer-to-peer transaction processing employee, right? James McKelvey created the original prototypes just like 20 minutes from here, 10 minutes from here in Menlo Park.
Terrific. You made reference to software, and I tried to compare software to engineering, but in fact, those things are not unrelated, right? So Jason, you You are involved both in manufacturing and software, and I think your company is described as bringing cloud to manufacturing. What does cloud have to do with manufacturing?
Every day that goes by, a lot more. I'll give you a little bit of just broader perspective on this question. I've been in enterprise software for 20 years, and over those 20 years, our industry has completely overhauled the technology architecture twice. Client-server, internet-based applications, and now a third time moving everything to the cloud. And the thing that's interesting about these changes is you always see the new architecture proved out in smaller functional areas of an enterprise. Starts out very often in sales or marketing or HR, even some of the areas of finance. And as the cloud has become more pervasive, we've seen that exact same technology adoption trend. And we've seen great companies like Salesforce.com, my old alumni company, Taleo, Concur, SuccessFactors. We've seen these companies prove out the model and deliver great software in these different functional areas of the enterprise. And then ultimately what tends to happen, again, based on these big technology shifts, manufacturers, they tend to be kind of in the middle of the adoption curve, or some people might even argue in the back of the adoption curve. And there's two reasons for that. One, it is such a mission-critical application for a manufacturing company. They can't afford to have their ERP system be down. So once the technology gets proved out in some of the other areas, manufacturers are more willing to adopt a new technology. It's also not trivial to build manufacturing software. The breadth and depth that's required in manufacturing software compared to some of the other solutions I mentioned earlier, it's just harder to build. So there's a longer time to build it. But I think what's really exciting right now is we are absolutely at an inflection point where manufacturing in the cloud is what's next. We're far enough into the cloud model. There are other great companies out there in the marketplace that have credible cloud offerings for manufacturing companies. And I think the next several years are going to see cloud adoption in manufacturing really take off. Because there are two things about cloud manufacturing that really, or excuse me, about the cloud that appeal. The barrier to entry and not having to buy big upfront software, hardware, and all that, being able to put your capital costs back into what is already a very capital-intensive business manufacturing is very attractive. And we've taken we, the broader software industry, have taken a very different approach to pricing in that it's success-based. So we ebb and flow with our customers. It's a more common thing across SaaS than the older models. So we are just getting started in this huge market, and I believe the delivery model is absolutely purpose-built for the manufacturing enterprise.
Terrific. So we've talked about the 24-hour fitness of manufacturing. We've talked about cloud software in manufacturing. Let's talk about some of the devices that actually manufacture. So Rod, you've spent several decades working in robotics. And so we've talked about robotics before. It's not the first time we've ever said the word robot. What's different now? What's going on in the robotics field that's changing?
Well, in the last 10 or 12 years, we've seen an uptake of robots that interact with ordinary people. The Roomba was an example of that. Ordinary people could have a robot in the home. The robots in the, and that's gone to over 10 million Roombas. Robots in the US military and the ground forces went from 0 to about 12,000, where 19-year-old kids are out there driving the robots, doing bomb defusing in Afghanistan and Iraq. More recently, we've seen Kiva Systems, which was bought by Amazon for almost $800 million, where the robots move shelves around and a person does the picking. So people and robots, they partitioned what was easy for a robot to do, move stuff in a straight line, and what was hard for a robot to do, pick out of a bin of parts and have the people do that, make the system more efficient. So we're starting to see robots and people come together to do things as a team. And I had been manufacturing in China for many years, and I saw a bunch of reasons that was not sustainable. We've been chasing low-cost labor, first to Japan, then Korea, then Taiwan, then mainland China, then down to Vietnam, and then pushing further into inland in China. We've reached, we talk about peak oil.
We're done.
We talk about peak oil.
Yeah.
In China, we've had peak 19-year-olds.
Yeah.
The demographics is going down again. So
robots are next.
the labor isn't there. The labor's getting more expensive, and the standard of living is going up, as it has in all those other countries. And after you get past Vietnam, where do you go? Well, maybe Thailand, except Thailand, by the way, was the 5th largest market for industrial robots last year because the Japanese have all their car factories there. So I started thinking about, could we, if labor is a problem in China, and then there's industrial IP, there's length of supply chain, and there's not having your engineers next to the manufacturing process. Next to manufacturing,
which is a disaster.
It's a disaster. So how could we bring things back? We had to replace that really mindless labor that happens in Chinese factories that no one in the US wants to do. You don't want to be a Chinese factory laborer in the US. So I moved to robots, but industrial robots are things that are mostly in automobile factories. They carry out a trajectory very accurately again and again, but that's the hammer, so you better make all your nails something that can hit. And thought about, what if we brought the sensibility of our PCs, our iPads, and our iPhones to automation equipment, where ordinary factory workers could get them set up to do a task in a few minutes or a couple of hours. And so that's what we've been doing, and building a two-armed robot that an ordinary factory worker can learn to train in a few minutes.
And you were telling me, how safe is it? You were giving
Yes. This is maybe a dangerous thing for a founder of a company, but all my engineers know that no matter what's happening with the robots, I will walk up and just put my head right in the way of the robot. Do not try that with a current industrial robot. You will die. But our robots...
It's confidence.
And they know they have to make that reliable and work.
It's a good test.
Yeah.
Marco, we just touched on another point where we started talking about the importance, or at least what it means to have design close to production, physically close to production. Say more about that, because that's not true all the time.
Yeah, so I grew up in old school, Avery Dennison, Kinko's, et cetera, where we have a stage-gated new product development process, and we do the design work and study and so forth, and we ship it somewhere, and then they get it wrong and they ship it back, and then we ship it back and they get it wrong again. And if you can do it in 3 iterations, you're actually doing reasonably well. And so you actually build your new product development process to assume that the first 3 iterations are wrong, and it's going to take days, if not weeks, if not months, to be able to run through those iterations. And so where I see one of the opportunities is obviously speed, and this is a classic study, Harvard Business Review, Clark and somebody, right? If you can, and any 6-month increase in new product development costs you half of your total profitability for the enterprise. So if you can reduce the cycle time that it takes you to actually do the development work, it's an incredible competitive advantage, and it actually creates profits. And so having long supply chains where you're doing design iterations internationally, it's interesting because you can work the 24-hour cycle, but between the languages and between the time, time sinks and the inability to describe what it is you're trying to do, versus literally walking down to the lab, doing the design, having somebody produce it, and then iterating inside of 8 hours, that crushes your competition. So the ability to rapidly reproduce what your design thinkers are thinking, whether it's 3D printing, whether it's using robots to do the cut and the make component and be able to assemble it and literally the next day show it to consumers and then iterate and iterate, iterate. I mean, we've got companies that are launching inside of the same time frame it took me to get approvals to do focus groups. I mean, that's, 90 days. So Dodo Case was one of them. Dodo Case, they came in and asked, what classes do I need to take to learn how to use the tools to launch my iPad case out of bamboo and bookbinding. So not only did they learn how to use the tools, then use the tools, then produce the product, and then launch the product, they did $1 million in sales in 90 days. And I explicitly remember a time where it took me more than a quarter to get approval to do the focus groups, which actually cost me exponentially more than what it took Patrick Buckley to launch his entire company.
That's remarkable.
If I can make a comment on that, when I started at Plex Systems, somebody said to me, wait, that's a US software company that sells software to US-based firms? I thought all manufacturing had been sent to China years ago and hadn't come home. And it's interesting meeting our customers and hearing very similar stories to what you just described, Mark. And I think the other kind of variant on that that's happened is the consumption economy just expects bespoke products today. And this customer was telling me, if you have a 15,000-mile long supply chain from design all the way to build, and then it's got to come back, you just can't be responsive enough to demand. And consumers are so fickle today because of the bespoke economy that we live in and have just come to embrace. I think it's another interesting thing that's just driven dramatic changes in where manufacturing gets done and the desire to get it closer to consumption.
Does that mean the jobs come back?
Well, that's an interesting question. I mean, you cited some stats off the top that certainly show, at least in the US, the job atrophy has stopped. And that is after, probably 2+ decades of it eroding. So jobs are coming back. Certainly, in the impact that technology's had on both the manufacturing and the service economy, I think it's similar. There's so many jobs across the economy that have been automated. But I think what you see in manufacturing, and it's technology like the robots we've been talking about, it's a higher end skill set that's required now in a factory, and the level of automation that's there, whether it's robots or modern day equipment, presses, are, they're basically an enormous computer. And so the skill set required to use them and the pay, frankly, associated with them is better.
Right.
Yeah, it's when you're not spending hundreds of billions of dollars, of US dollars in China per year to do manufacturing there, and instead spending it in our economy if it were to all come back, that's got to be more jobs of some sort, but it's not the jobs that are the jobs that are in China. They're different jobs. I think there's still a lot of room for us to make machines easier to use.
I would agree.
This was brought home to me. I'll make an MIT joke here, okay? He's been nudging me about MIT.
This will be good.
I love MIT.
We had at iRobot we had the PackBot out in Iraq and Afghanistan. Yeah. A great architecture. There was a competitor, also from Massachusetts, Foster Miller, which was bought by Kinetic. And we thought their robots sucked compared to us. It had analog systems. It didn't have the digital backbone that we had. We had this, user interface built by an MIT engineer that could do anything. Couldn't do it with the other robot. Word came back from the field, from the 19-year-old soldiers out there, that our robots sucked. Not theirs, ours sucked, because it was hard to use, because the user interface was so complicated. The MIT engineer said, well, we need smarter users then. Wrong answer. The right answer was to adapt the Game Boy controller.
Right, yeah. That was
Zero training,
brilliant
5 minutes of playing were better than with 2 months of training with the old interface. You could not do everything with the Game Boy controller, but you could do far more than anyone was being able to do with the complex interface. So making the interfaces easy to use, which inside factories and manufacturing engineers, I see a certain amount of, well, machines are complicated, but we have to, if we had that thought about our smartphones, you can jailbreak it, or if it's an Android, you don't even need to do that. And you can type a Unix command to make a phone call, but that's not what we want to do. We want to make it easy to use, right? And there's still more ease of use, I think, to be had.
Fair point.
I did go to my director and type LS at one point. I'm kidding. So interesting, right? I mean, one of the things that we found in the Valley is this return to design, right? And particularly hardware design, amongst other things, as a source of competitive advantage for products. And Mark, I'll ask you. There seems to be a resurgence in the Valley.
Well, yeah. So I actually, so my view of history is that we've been makers for eons, or at least thousands of years, and up until the Industrial Revolution, we've individually been engaged in making whatever it is that we needed to design and develop. We had this bizarre 150, 200-year interjection called the Industrial Revolution, where tools were really expensive and most of us didn't have access to them because of that. Now they've actually become cheap, easy, and powerful. And then we've had this incredibly bizarre 30-year hiatus where all we cared about was software design and code and the UI. Frankly, perhaps to my dismay, I don't live on the screen, Sherry Turkle notwithstanding. I don't live on the screen. I live in RL. I live in the real world. And most of these products that I engage with every day are physical. They do have a UI component to it. And so I would argue that for the last 20 years, we've just been in this very bizarre epoch era that is going away, and we're going back to what we've always been, which is, you know, physically enabled, physically engaged. We make our own tools, we make our own things, and the people who make things are the ones that actually matter. The code is interesting and is actually cheap and abundant and easy, relatively speaking. And so the hard part is making, you know, beautiful clothing and beautiful cabinets and beautiful cars and beautiful things that I would actually engage in. And so I think it's interesting. It'll be, we'll see over the next 10 or 15 years. And I want to go back to this. You know, who wants that job, right? So you asked manufacturing, right? So no, the answer is no. Those jobs are not coming back, at least not in the numbers that we shipped off. But who wants those jobs? How much better is it to do the design piece, to do the anthropological piece, to understand how the consumer actually wants to engage and use your product? That is really interesting. Screwing a little 10 millimeter screw with a, you know, 5 micron, whatever, that is not a lot of fun. And that is perfect for robots. And so thank goodness that stuff is coming back to the US and robots are doing it, because now we have a short manufacturing chain where the designers then can see how the manufacturing works and they can engage directly in the end user experience, which is really what matters.
Right.
Just two things. At ReThink Robotics, as we were starting to design our robot, we went out into lots of US factories, talked to factory workers, to find out how they thought, how they would do things so we could make a tool they could use. But one of the questions we asked them was, do you want your kids to work in a factory like this? 0 of them said yes. They did not want their kids to be there. And in fact, if you look at a lot of US companies, their manufacturing workforce is getting older and older because people don't want those jobs. The other thing I'll say about going back after this 230-year change, we're going back in a different way because a lot of the products combine software and hardware.
Absolutely. Yeah.
And the software lets you compensate and bring down the cost of the hardware because you can't break the laws of physics, but you can do a lot in software. And in the maker movement, the Arduino system is a great example of that.
Yeah, exactly.
It's let all sorts of new things flower because it's so easy to use and couple into the mechanical system.
Yeah, I mean, a lot of our members we bring in, we teach them how to use an Arduino, and it like takes a week and a half. You got to be reasonably smart, but maybe a week and a half. And then they prototype something fairly sophisticated.
Do people know what Arduino is? Is that?
For those who don't.
Yeah, so Arduino is a board that hides an incredible amount of complexity associated with creating microcontrolled components. So where you used to use an Atmel chip along with maybe assembly language to be able to control it, you now actually have like a Visual Basic type of a programming language that will allow you to do input-output, which a lot of our members then do to create a Kickstarter campaign to launch an interesting and amazing companies. And then they go hire an Atmel assembly programmer to design the chip. Once they've proven there's a market, they've got $400,000 in one instance of sales, then they can go back and actually kind of upgrade it. So the ability to prototype something literally this week, get consumer demand, confirm that it exists, and then go back and do the hard lifting, we've never seen that before.
I was just going to say, one of the other things that I think is really cool about a lot of entrepreneurs out here in Silicon Valley right now is the focus on integrated hardware and software devices. And having lived out here for 20 years now, we've always focused so much on software. That has kind of been the golden era of software, whether it's been B2B or B2C. And now with networking so pervasive and connectivity to the internet, there's just this whole new opportunity to revolutionize everyday household things by having an operating system on them and connecting them to the internet and being able to control them remotely. There's just great examples of that kind of innovation going on in Silicon Valley, whether it's Tesla cars, which everyone said you can't build an electric car, you can't build a car that's run on software that gets automatic updates. The Nest thermostat, all the things that are popping up every single day on Kickstarter. Increasingly, you're seeing a really unique, innovative combination of IP-enabled devices that have great software on them.
Do you think we're seeing a world where that integration is resulting in more closed systems? Because the software is integrated?
No, actually, no, it's going the other direction. And so shout out to my Ford friends that are here. Right, so they've done an OpenXE platform where you now have access to the data that comes out of their Kanban system. I don't even know what that means, but they've got an operating system that creates data. They've got, So Andreessen's right at one level, right? Software's consuming the world. I actually disagree completely at another level because it can't fundamentally. That's what makes it interesting. It's an oxymoron, right? By definition, software can't consume the world.
Because it has no mouth.
Because it, exactly, right? And so Ford, and then of course Intel recently announced the Galileo platform that layers on the Arduino. You know, so this interface between hardware and software is becoming easier and easier and more powerful, and thankfully, large industrial companies are not closing in, they're actually opening up. And Ford and General Electric and Intel, three of our partners, are actually opening up their systems and able to tap the, you know, the embedded creative class in the United States.
Rod, I'm curious, you know, you have a robot. To what extent are you going to open it up and, you know, let other people?
Well, yeah, starting in May, we started shipping a version, the same physical platform, but with an open SDK, open source, built on ROS, the robot operating system from Willow Garage, just a mile or two away from here. That's started going out into universities. It's in lots of universities now. People are going to use that robot to do all sorts of weird stuff. And I harken back. When I came to Stanford in 1977, I came to work on a mobile robot. And there were three, from Australia, there were three mobile robots that I knew of in the world at that point. One was at Stanford, one at JPL, and one in France. Not many people working on mobile robots. In the 80s and early 90s, a bunch of companies started putting out low-cost mobile platforms, including iRobot. And before long, there were thousands of people working on mobile robots. Then they started doing simultaneous localization and mapping, which is the SLAM, which is the basis of all the self-driving cars that are now getting out there. And you know, Nissan announced a few weeks ago they're going to have a fully self-driving car by 2020. Google, of course, has had their driving on the freeway car. But that came from having thousands of people being able to do the experiments, which is why I put the Baxter out there into research labs, and it's just taken off since May.
Wow. Well, let's turn to business a little bit more. Are there implications, Rod, why don't we start with you, implications for business models of all the things that we're seeing happen in manufacturing?
Yeah, so let me give a sort of a wacky example, and I don't know whether this will come true, but it just sort of makes you think about how things would work. You know, at the moment, well, up until fairly recently, a product design company has built a design. They've gone and figured out how to manufacture it in China. Then the stuff gets shipped to the US to distributors, gets shipped around the country, and then gets sold either online or in physical stores. As we get 3D printing better and better, as we get CAD to be much more parametric, to include a lot of the manufacturing processes in the CAD, much more comprehensive CAD, I call it super CAD. Here's a different business model for a product company in the future. Product company in the future builds a CAD package which includes all the manufacturing content, and then places all over the country, you know, maybe you know, in an MFG.com style thing, say, I'm going to manufacture them, and maybe they, or maybe it's Walmart says, I want 30,000 in Kansas, I want 50,000 in Seattle, and they get built in totally independent TechShop-y-like things.
Like Kinko's 3.0.
And then they get pushed out into directly to the consumer. And maybe they get customized in different places on top of that. So the who does what could change radically. That's one example. There'll be lots and lots of different examples, but and it's hard to imagine what they are. A friend of mine started a company 3 years ago, which he sold to Twitter recently, which is a Twitter analytics company. Who knew we needed Twitter analytics until 3 years ago? So what the shape of these little companies will be, but that's what Silicon Valley did for the last 30 years. It completely changed what the business models were again and again and again.
So we see these new business models, and yet, Jason, your company came from a set of manufacturers that have been around for many, many years. It's interesting. I mean, you're based here, but a lot of your company is based in the Midwest. What does that mean to have a company that's a high-tech company and yet has its roots in these much older companies?
Yeah, we're headquartered actually in Michigan, and it's like anything in business. There's two sides to the coin. The positive thing about being headquartered in Michigan is our company grew up in the heartland. We grew up in a manufacturing hotbed, and whether we're selling in the Midwest or the Northeast or the Southeast or Southwest, we have a lot of credibility because we come from manufacturing. It is absolutely in our DNA. The other thing we were talking about before the panel, and a lot of people out here don't know this, and I maybe shouldn't share it because it's part of our secret sauce. There is phenomenal engineering talent in the Midwest. The Big Ten universities pump out engineering grads, just as good as the technical universities out here. So being able to provide an engineering graduate with a Silicon Valley-like employment experience where they can live like a country squire for $200,000 in this enormous house is it is pretty attractive. But the market there, the talent pool is a bit constrained. I mean, we have some great marketing folks and some great sales folks on our team, but as a growing tech company, as many of you in the audience know, tech companies have a voracious appetite for sales and marketing expertise, and the talent pool just isn't big enough in Michigan yet, or even in the Midwest. And so we've had to establish a beachhead out here. In fact, we've spent our first week in our brand spanking new office out here in the West Coast. And that'll be a beachhead for us to continue to augment our existing sales and marketing talent, some of the other things that we can't find in the Midwest and ready supply.
And where are the locations of the tech shops? It's actually quite interesting.
Yeah, so we have 6, 3 in the Bay Area, and then Detroit, Allen Park with Ford, Pittsburgh, great city for manufacturing, by the way. That was a DARPA Veterans Administration funded location. Lowe's Home Improvement helped us open in Austin, Texas. And Phoenix is about to open next month, and then we've got DC on the way.
And Rod, where is ReThink?
ReThink is in Boston. We manufacture the robot in the U.S. Every custom part is built in the U.S. We have 19 primary suppliers, 4 sub-assembly suppliers, and 1 final assembly place. And it's in about 13 or 14 states across the country, from Washington State.
Was that a strategic decision that you were going to?
Well, we decided we were going to manufacture in the U.S. because we're talking about manufacturing in the U.S. We better do it. And by the way, the robot comes out at the base robot with 2 7-degree of freedom arms and a head is $22,000, which is way cheaper than any industrial robot by a factor of 4.
Why does it have a head?
Oh, okay. Let me just finish the manufacturing and get back to the head. So the reason we have it in so many places, we didn't design the robot and then throw it over the fence to manufacturing. We thought about what sort of processes we needed for each part, went out and found the right supplier, worked with them, find out their process, and then aim our design at the middle of their process. So
Right.
And so then, when we designed the thing, it was easy for them to build, so it was cheap. So we had the cost in there first. Why the head? There's a screen as the head. When you're training the robot, that follows you around so you can see stuff on there. But when it's just working, it's got 2 eyes. Why eyes?
It's anthropomorphic. It's
anthropomorphic, but what it does is, if it's about to reach over there, it glances there first and then it reaches. So if you're a factory worker and you're near it, you're never surprised by what it does because it makes a promise for what it's about to do and delivers on that promise. We ask factory workers who've been around the robot, why has it got eyes? And they say, well, it looks when it's about to reach, so you know what it's going to do, and that's why it's there.
But the cameras are actually not there, right?
There is a camera here, but there's cameras in the hand too, and that's how it sees things.
Yeah. What sort of machinery do you have in the tech shop that people can use?
So, I mean, we have all the tools of the Industrial Revolution. So machine tools, mills, and lathes, computer numerically controlled mills, importantly. The CNC piece is the radical piece. A complete woodworking shop, including a computer numerically controlled router, laser cutters, 3D printers, textiles, complete plastics lab, complete electronics lab. I mean, we like to say everything you need to make anything on the planet. It's a slight exaggeration, right? We don't do glass. We don't do ceramics. There's usually a good glass and ceramic studio in every major city. But there isn't a studio where you can go in and start welding, which is the unique piece. So we'll teach you how to weld this evening. If you've got time, you can run over to Menlo Park, jump into a class, and learn how to weld this evening.
By the way, do you have an announcement to make about the...
Yes, for those of you who are Menlo Park members, we have signed a letter of intent. We're moving to San Carlos temporarily. And then within a 3-mile radius, we'll open the final TechShop Menlo Park, which will match all of the great locations that we have across the US. So the Menlo Park was the beta location. It was started by Jim Newton, and we have some used equipment, and it looks a little run down compared to, say, San Jose or Pittsburgh or Detroit. So we're planning on upgrading it.
It's not often you can use that phrase.
No.
3D printing, you mentioned you have 3D printers.
Oh, yeah.
A lot of people think that that's really disruptive technology.
Yes and no, right? So 3D printers are amazing because you can prototype things radically, rapidly, you know, like right now. It's turned me into a hero at home, remarkably enough. So my wife developed an allergy to flowers about 3 or 4 years ago, and so, you know, now I can't like run to the grocery store on February 14th and I have to go to Tiffany's, which is what I did a couple of years ago. A little more expensive, takes a little planning. There's one, you know, there's not one right next door. Now I have a 3D printer. So this last time what I did was I downloaded using Thingiverse a 3D model of a rose, and I printed the rose out using really nasty PLA green neon. She was thrilled because I made it, right? So I love 3D printers. It's improved my home life significantly.
Cheaper now.
Can I just say, you know, and people, you know, think, well, 3D printers aren't, you know, you can't do mass production, but they can assist. So, for instance, our robots are out there. We don't have a hand that's this good, so people customize the hands, and they're using 3D printers to print the fingers, and that's just how people are using our robots.
Yeah,
augmenting them with 3D
and what is
printers.
mass production? So it turns out 3D printers are good up. If you're doing 3,000 units or less, it's a fairly competitive platform, according to a recent study. If you're doing more than 3,000 units, then you're going to want to migrate to a newer technology. But as a result of the internet and manufacturing technologies, there was a recent Research Science Foundation did longitudinal study on eBay that asked the question, you know, what's happening with the long tail? And it turns out it's getting fatter. And so that means there are more mid-sized manufacturers today and transactions today than there were a decade ago. Now, some of that is driven just because of Ron Coase and the transaction cost and so forth, but I believe some of that is being driven by manufacturing. And as we see robots introduced into manufacturing that enable us to customize, personalize, and run shorter runs cost effectively, you're going to see that tail continue to get fatter and fatter and fatter. So I am very hopeful for the mid-sized and short-run manufacturer in the United States, or actually any local. So if you think about supply chains, we've got amazing software that will manage supply chains literally across the world. But what I want them to do is to readopt that supply chain so that when I go into IKEA or the equivalent, or actually TechShop in the future, and I say, I want that IKEA design furniture, and I want that morphed with my Ethan Allen design, and I want it in redwood. Actually, I don't just want it in redwood. I want it in locally sourced, reclaimed redwood from a barn in Napa Valley. And the supply chain software component to that cost nothing. So you'll be able to reach into your supply chain, find those small batches, pull them forward, and create a bespoke that has potentially, you know, my children's photograph re-rendered in 3D on that. For what, 20% more than I might have gone into the IKEA and bought that piece of garbage? Who would not pay an extra 20% for a redwood reclaimed that you helped design to be in your dining room? Just about anybody. Now the college student is still going to go to IKEA, but the rest of the world is going to say, I want my bespoke piece, and it's not going to cost that much more. And it's thanks to advanced manufacturing, software, and robotics that world will exist.
Jason, a lot of your customers are in fact these small and medium manufacturers. Is that what you're actually seeing them do?
Yeah, absolutely. Yes.
Okay,
I don't have anything to add to that eloquent.
Paying you almost nothing.
Right, I'm curious. You know, there are likely entrepreneurs who have physical products that they're designing, developing, et cetera. When is it appropriate, or how should they think about the use of robotics for production?
Well, there's different sorts of robots for different sorts of things. And you know, the accurate robots still take much more sophisticated training to do really precise stuff. It's not magic at the moment. It may become magic as the CAD reaches down into there and pushes all the way down. At the moment, though, the more precision that's required, the more you have to understand the geometry to get it to work. For our robot, we're really moving right now, doing a lot with third-party logistics, 3PL, because that's an industry where what they do changes every few days. Their line that they set up today will not be there next week, and so having something that is easily retrained is very important.
Let's give the audience a chance to ask some questions. So I know we have microphones out there. Just raise your hand. And
so while we wait, let me talk about the prototype, right? So let's not lose that. So the ability to use 3D printing and to be able to use CAD, CAM, and designs to be able to create the prototype so you can show management what it is that you're trying to do. I call that a management device. Because managers are idiots. I mean, I'm an idiot. I've been there, and I can't understand hand-waving and PowerPoints. If you show me the physical product, I get it. So our penultimate example is Jack Dorsey, James McKelvey, and Square, right? And for those of you who don't know, famously, they failed in convincing the smartest people on the planet to fund them until they had the prototype. When they had the prototype, they raised 10 million just like that. Prior to that, they shut them down. Until you have a prototype, basically you have nothing. I mean, if Jack Dorsey can't convince Andreessen to fund his startup until he gives him a prototype, your employees are doomed until they have the prototype. So there's the power of 3D printing. No, it's not a panacea. It's not going to do everything short term, but it will help you build a prototype. So that should be enough time to get a question or two.
In addition to improving your home life. All right, first question, go ahead.
Is this thing on? Yes. Burton Lee, Stanford Mechanical Engineering. So this panel is entitled The New Faces of Manufacturing. I've just returned from a month-long visit to Germany, where I've been inside numerous manufacturing research laboratories inside German universities. And I see them developing entire new processes around manufacturing that are almost non-existent here in the USA. This includes new machine tool development. The panel today has been very interesting about addressing 3D printing, integration of IT into manufacturing, assembly processes. However, I don't think that's the full story about manufacturing. I think we're missing a big picture and piece of what's really happening globally in manufacturing and where the USA needs to go. And I'd like your comments on that as to whether the dialogue here in the USA about the state of US manufacturing is really where it needs to be, about the hollowing out of US manufacturing capacity over the past 20 years. In my view, we're not having the right discussion. We're too enamored of 3D printing and additive technologies. We're not addressing some of the core hollowing out issues, which are not going to be fixed by 3D printing. Any comments from any of the panelists?
None of us are building 3D printers. We're building other parts of the manufacturing process. You know, it's great what the Germans are doing. It's important, but that's not the whole picture either. There's lots of components here that come together. I think in the US that for many years there was a push on advanced manufacturing, and there was a mistake, a semantic mistake, considering that advanced manufacturing meant manufacturing really advanced stuff like jet engines, rather than using advanced technology to manufacture ordinary stuff. And so but that's a complex interplay. So maybe you could be more specific about what it is you saw in Germany that we are totally missing. I'm not sure what you meant.
Well, I'd have to go into details which may be too technical. So fiber reinforced concrete systems, fiber reinforced clothing, other metallic components, integration of multiple processes, technologies into extrusion, fibers and extrusion, very specialty components that simply, this kind of stuff, new machine tool development is not being done in most research laboratories here in the US as far as I can tell, either university or corporate.
Here's an example. One of the reasons our robot is so cheap is because the gears we use are made from powdered metal rather than cut from steel. That technique was developed at Penn State. So every company that's good at that is in central Pennsylvania, and that's why we manufacture our gears in central Pennsylvania. So there are people working on new techniques around the US.
So I agree with you completely. A panel like this, you can't hit them all. But so let's hit two that we also didn't talk about that I think are absolutely critical, and one layers into the other. And I think actually the enamoring that we've got with additive manufacturing is helping, and that's attracting people to mechanical engineering and manufacturing and science, technology, engineering, and math fields. We are absolutely abysmal at this at every level in the United States, as far as I'm concerned, and the Germans are certainly way ahead of us in that regard, and the Chinese, and some level, the Indians are as well. And so if anything, this additive manufacturing hype is created an opportunity for us to get junior high kids and younger excited about science, technology, engineering, and math, whether it's fiber technology or other thing. And so in that regard, I'm hopeful. And then if we like hone that even further for the women in the room, 14% of the engineers in the United States are engineers. That is, or 14% of the engineers are women. That is an absolute, utter travesty and disaster. It is our biggest opportunity globally to solve the world's problems, is to get women and girls, 8 to 12, excited about science, technology, engineering, and math. And I don't care if it's, I don't care if it's 3D printing or what it is that gets them excited about it. If we can get the girls excited about engineering and math and get them into our schools, then we have some hope. So I mean, this panel can't cover all of those, but thank you for raising the issue on the things we haven't covered.
Next question.
Hello. So there's been a lot of talk about additive manufacturing, as in the 3D printing you're talking about, but those machines, they cost around $5,000, $4,000. But what I have at home is called a CNC mill. It cost me $900.
That's subtractive manufacturing.
That's subtractive manufacturing. It cost me $900. I spent an extra $300 on a water-cooled spindle, and I spent $100 on the CAM software. And I can make not only, the problem with additive manufacturing is you can only use certain types of plastic. But with subtractive, with my CNC machine, I can cut anything. Ceramic, glass, metal, plastic, whatever you name it. And my costs are much less than, I don't have to go buy the special plastic to put into a 3D printing machine. I can use whatever material. I can use aluminum, I can use wood, whatever I want. And so I think a lot of this is 3D printing is hype, because you're spending 5 times more money to buy the machine, and then you're spending also on these special plastics you have to put in the machine. And then our study is, they compared it against, hard tooling. Well, the thing is, hard tooling might be 5,000 units, but with a CNC machine, we have what's called soft tooling. And there, it's much more competitive, and you can do whatever a 3D printing machine can do, and much more.
So I think the question is 3D printing hyped?
Yeah, well, you're not going to get me to defend it. You're absolutely right. Computer numerically controlled machines and the software, most importantly, associated with being able to drive those, I think is the real revolution that's going on kind of under the surface. And so one of our partners is Autodesk, and it was actually very cool, because literally our very first conversation with the entire senior team was, your software is too hard. You have to fix that. We'll be glad to help, but your software is too hard. And since then, they've launched a consumer division, and they're working on making it simpler. They're buying companies like Tinkercad to make it easier and easier. And I don't know, 10, 15% of the stuff is now 3D printed. you know, but it doesn't have the shear, it doesn't have compression, it's not the same as a CNC controlled tool. But again, if that's what's sexy right now, and that gets kids involved, and that gets an audience to show up, and we can get them engaged about, you know, you're going to use the software one way or the other. You're going to use the software to do the modeling, and then you're going to have to choose, how am I going to make it? And it turns out like 80% of the time or more, CNC is just it's just a better system for being able to do it. Uniquely, occasionally, you know, a 3D printer is better.
And you can buy them for $1,200 out of the airline magazine. Next question.
Out of the airline magazine, yes.
No kidding. I'm not joking. United. No commercial. Next question. Yeah, way over there.
Hi.
Please.
Yes, whether it's 3D printing or something else, it seems that there is always an ecosystem that comes along with it. I mean, you mentioned there are Thingiverse and some other things that give you designs. So isn't the real driver and the real opportunity here for the new phases of manufacturing design? Could you guys comment on how that area is addressed, invested on, beyond just looking for more parametric design on CAD software? Thanks.
The comment I would make on that, I was going to make it on some of the earlier comments on 3D printing. I look at my own experience with that. I run a software company that employs a couple hundred software engineers. Many of them, not all of them, would never go buy a CNC machine. They're much more comfortable using 3D printing. And so I think one of the thing that's unique about that, as CNC is and some of the other tools, is it democratizes the tools to different people who now have access to create and design their own prototypes in a technology and an environment that they're comfortable in, which I think is actually the more interesting thing about 3D. It's not going to replace some of these other things. It's additive, and it spreads out the ability to create.
Additive more than one way. Next question.
Hello, I'm a Santa Clara student, and I have a question regarding 3D printing. So I really agree with that it's a social entrepreneurship. The benefit that will be solved the problem of many. And especially in South America or maybe developing countries. So I wonder how do you see 3D printing helping or people investing or investors investing in 3D printing in developing countries? How do you see you know, the developing of these maybe not affordable 3D printing in developing countries? Especially in the health industry, because there are so many. How you see many people with amputees, many people with disabilities. So, how do you see the 3D printing can help these people in the 3D world? And also, the other question I have is also regarding the legal issues that arise by designing and also printing patented or copyrighted designs or patented products. So how do you see the future of the 3D printing maybe arising a lot of problems, you know? Or what is your perspective? What can be the approach that will solve this issue, possible issue?
I'll take the last one first. So, yes, it's a great question, the IP question. So here's the answer. If you don't put your IP up for a reasonable rate, we're going to steal it. Get over it. We've been there, done that, right? We saw Napster do it. We saw the music industry do it. We saw the movies do that. The trick was that the folks who controlled that IP weren't willing to put their IP up at a reasonable rate until Steve Jobs forced it down their throat. And 30% of their total value chain ended up here in Cupertino. So if the world wants to give their IP at reasonable rates, people will pay it. They would rather, trust me, it's even harder when you do 3 dimensions. Being able to convert something in 3 dimension into whether it's redwood or maple or walnut or steel or plastic is actually pretty hard. And so there's a reasonable rate that you will be willing to pay for that IP. But if IKEA and Levi's and others refuse to put that IP out there where you can get it, I'm sorry, we will steal it collectively. I won't personally, but we will steal it. So I don't know, it's like, this is history. We've been there, we've done that, we know what the right solution is. Hopefully somebody will come up and solve that. And if it has to be Apple, then so be it.
Anyone want to take a crack? Let's maybe not just keep it at 3D printing, but we've talked a lot about reshoring manufacturing facilities to high-cost areas. Is there a case for investing in manufacturing, advanced manufacturing the way Rod described it, the use of advanced techniques in developing countries?
Well, I think as the cost of these techniques comes down, it makes sense to do things locally for any economy. You know, when I remember there was a real argument made when cell phones came out. Some people were saying, once again, the third world is going to get left behind. You know, it's only going to be the first world has cell phones. And what happened? It was the developing world that adopted them and used them for payment systems and all sorts of things that we still don't really have in the US. So I think as the cost of these things come down, they will be taken up all over the world, and there will be local manufacturing because it makes economic sense to do it locally when the cost comes down.
And we've talked a lot about moving manufacturing from other countries, but those other countries are also investing in robots and automation and additive and CMC and everything else. Yeah.
I was just going to say, I think at least in our customer base, and we have a lot of automotive customers, one of the other trends you see going on that is driving technology into emerging economies is many supply chains have coalesced vertically within regions. And so if you look at the auto industry, pretty much any auto you buy here, regardless of the nameplate, it's built here. Same thing in Asia, same thing in EMEA. So there's been a lot of cross-pollination on some of the process work and the technology work that's happened in these isolated regions as these big multinationals have now regionalized their supply chain. And so I think they're bringing great technology into the theaters, and they're being used more pervasively in economies that used to just rely on manual labor.
Were you also telling me that some of your medium-sized businesses have subsidiaries or supply chains that also stretch into?
Yeah, it's fascinating. If you look at the automotive supply chain, kind of at the bottom, the long tail of the automotive supply chain, there's this collection of $10 to $15 million metal stampers that are based in exotic places like Grand Haven, Michigan. None of you have probably ever heard of that. One of our customers are a $15 million business in Grand Haven, Michigan, yet they've got operations in China to support the automotive supply chain there. They've got operations, obviously, in the Midwest to support North America, and also operations in Europe. So the complexity for what has historically been a Midwest-based manufacturer the geography lens has made their business quite interesting.
Yeah, I think people often get confused about which way things go. The Tata Nano, which is the $2,000 car in India, uses an electronic system made by Bosch.
Next question. Whoever has a microphone, go ahead.
I have a question. We had discussed at the beginning about the cloud and its pervasiveness, and now we're talking about manufacturing, and there was the discussion that we're now going to be moving toward a multi-tenant manufacturing facility, similar to the way that the cloud evolved over several decades. Do you see this coming into a multi-tenant business model the same way that the cloud did, looking at distributed services, their business models, and finding a way to create open source as a functional model? Or do you think the manufacturing community is going to make their own model for how multi-tenant manufacturing is going to be?
I think it depends. Certain industries tend to be a lot more collaborative in process and sharing production IP. Food and beverage is one example, tends to be fairly collaborative across their supply chain. Aerospace and defense doesn't. So I don't know that there's a one-size-fits-all to that answer in terms of how technology and process and best practices get shared. It is somewhat, at least looking at our customer base, somewhat industry dependent. You know, I'm not sure I 100% understand the question, but certainly the benefits of multi-tenant software and getting access to it and being able to run multi-plant, multinational software enterprises in the cloud is, I mean, as I talked about in my opening remarks, it's a huge benefit.
A couple more questions before we go to the lightning round.
I just want to say one thing which I haven't, and I may just be missing it in manufacturing, hasn't happened but could happen, is as these services become better defined, maybe we'll get whole sorts of franchising things happening in manufacturing, which is something we haven't seen yet, but it could arise, be attached to tech shops, and then follow them all over the country.
Yeah, but, so my guess on that is it depends on your scale. So, I mean, again, as an old line manufacturing guy, our objective when we put a manufacturing line in was to keep it as busy as we possibly could. And if you can keep it busy all the time, then you create a closed system, you create IP around it, and you block everybody out. If you can't do that, then you start looking at, well, how do I bring other folks in to be able to leverage that particular asset? I suspect that because of the software and modularization, we're going to see more of the latter, where you're going to see more open manufacturing facilities where people can do more interesting things. And you already see that to some extent. I mean, between Alibaba and MFG.com, you can prototype just about anything on the planet. I mean, it's a remarkable ecosystem that already exists. The trick then becomes, you know, when you're dealing with commodities where your margins are very thin, you have to build the scale, and Alibaba and MFG.com are not going to solve that problem. So so you've got to be able to invest in it. It becomes capital intensive, and then you look at your IP. So so there's just a pure economic piece, right? Do I build my economies of scale and try to protect it? Do I try to use an integrated, distributed model and not necessarily protect it? And then there's a subtle piece, which is the philosophical one that you're asking around, you know, should I be more open source or not? And, you know, it's going to vary, obviously, depending on what it is you're trying to manufacture and what it is that your particular strategy is for going into each of these markets. And you can make solid arguments for each one of those spheres.
Next question.
As the capabilities for manufacturing new technologies start to become easier to use, more cost efficient, and more exotic, what are some of the challenges of integrating all of these? Because it seems to me from listening here, a lot of this is cellular based, so we're going after this particular cell, and just like we've always had in manufacturing, and we've improved that process, and we've gotten it to a level where we've got the cost down and optimized the quality. How when you look at 2 to 3 years, what are the major challenges? Because we've always had this problem with integrating all of that technology. And then the second question is, where's the manufacturing management system going that's integrating across the enterprise or even the enterprise to make sure that everything is in sync? Because those challenges probably start to multiply with the more introductions of technology we have.
Yeah, I'll take an initial cut at that. I actually think the technology refresh that's going on in manufacturing right now, whether it's new CNC machines or presses that are completely automated and actually have an open API so you can plug into them, or robots that have an open API that can plug into them, or modern ERP systems that are cloud-based where everyone's on the same release and it's easy to plug in. I think the technology refresh that we're going through at least is getting us for all of those major components in a factory on a modern technology platform to make that integration easier. If you go into a plant today that hasn't started that refresh, you've got customers that are, or you've got businesses that are marooned on old versions of ERP systems that are proprietary and closed. You don't have a snowball's chance in hell to integrate that with or use that system to orchestrate new robots, new machines. And so I think this technology refresh is actually going to make that fabric of technology in the enterprise or in a manufacturing plant much easier, or relatively easier to integrate than it has been in the past.
One last question, or we're going to go to the lightning round.
Hi.
It's time. Oh, did I hear one?
Yes. Hi.
Go ahead.
Hi, my name is E, and I'm from Fora. I wanted to ask a question. There seems to be some level of agreement around the general idea that we're done chasing cheaper labor. But when you look at certain statistics, you're looking at continents like Africa, which are still kind of benefiting from like the demographic bulge or dividend. And for example, Africa is going to have largest workforce on Earth by 2035. And so, first question, are we really done chasing cheaper labor? And second question is, if we are done chasing cheaper labor, what is that highly volatile population of people going to do? And what kind of danger does that portend for national security or global security? And have those impacts been considered in terms of where we're going with manufacturing?
I have a slightly contrarian view on chasing cheap labor. I think, again, in some of these industries we've talked about tonight where supply chains have verticalized in a theater, I think the companies that are doing that are still doing labor arbitrage, just on a smaller scale within a theater. And they're doing it based on both cost as well as skills that happen to be more readily available in that particular country or a particular region. So I do still think there is opportunity with these regionalized supply chains to continue to wring out costs and drive better productivity based on the different skill mix in the region.
Great. All right, it's time for the lightning round. There's a series of quick questions and a series of quick answers. Let us begin.
Are you going to direct them at us, or do we all answer?
You will all answer every question, unless you choose to pass.
I thought you said we could pass.
You can pass. Jason, what types of products are most likely to be disrupted by new advances in manufacturing?
I think the biggest opportunity in manufacturing as companies move to the cloud and get on standard platforms is to leverage all the data that's being collected in manufacturing firms today. Manufacturing firms, hundreds of sensors in them. Modern technology is just catching up to be able to make sense of it.
What types of products that are being manufactured?
What types of products? I think it's some of the things we've talked about tonight. I think there's really an opportunity in any of these different industries to drive better products, bespoke products, and getting them closer to consumption.
Rod?
I'll take a slightly different angle on it. I think the technologies for printing electronics into products are going to change the nature of products over the next few years.
Mark?
So I'll use Square as the example. So you got to think about manufacturing in an extremely broad sense. So they couldn't get the deal until they showed the demo. Once they showed the demo, they completely upended the entire merchant banking industry in the United States. And they're giving their hardware away.
Because of a 3D printer?
Well, yeah. So it's a little piece of plastic with a little bit of electronics. So it turns out smartphones are really a remarkable platform. You got a computer in your pocket. So what other things are we going to attach to that, and what industries are we going to upset? And I would not have chosen the merchant banking industry as the obvious one 3 years ago.
Mark, what types of products is it most important to have design co-located with production?
So anything that has the personalization component clearly needs to be closer, and then not intuitively the most mass production products. You need to have your designer right there producing it and understanding what the manufacturing capabilities are. So the tighter that part of the supply chain is, the more important it is. And I've seen it where we exported our designer to Japan to be on site for 6 weeks to figure out how to produce the component that we were buying from Japan.
Right.
I think anything that has electromechanical with motion in it, you need to. I've exported lots of engineers to China to sit there for months and months and months to make it work right.
Like robots. Jason?
I think the most compelling story I heard on this topic was General Electric's story around some of the more complex things that they build, like jet engines, where the design and just very simple changes in the degrees of a fan blade in an engine make huge differences in thrust and safety.
For what types of products is it least important to have design co-located? Jason?
Commodities.
Ryan?
Printing.
Socks.
It also can be somewhere else.
Socks, okay. For what country will be the most surprising manufacturing power in 5 years? Mark?
Say that again?
What country will be the most surprising manufacturing country in 5 years?
I'll pass, I don't know.
Kenya.
Brazil.
Ah, interesting. What state will be, what U.S. state will be the most surprising manufacturing powerhouse in 5 years?
Michigan.
Homer. Homer. Right.
Surprising. Oh.
Alabama.
So our next location is Phoenix, so I'll do a shout out to Arizona.
That's good. Which company has the most to gain from new advances in manufacturing, Mark?
Actually, I think the largest current players, if they get it right, so General Electric comes to mind.
Rod?
Yeah, I think we're going to, we start to see Apple trying to pull things back. I think a lot of the tech companies, for a mixture of reasons, are going to want to bring manufacturing closer to them.
Jason?
I would go with Caterpillar. Caterpillar's a really interesting story. They used to outsource all of their manufacturing, and they realized they were having quality problems because they couldn't enforce their quality standards from the design process into manufacturing. They pulled it all back. Every dump truck, large engine in a generator that you see that's Caterpillar, it's built down in Texas, and they've driven better quality, and it's lower cost, easier to maintain.
Which company has the most to lose?
But the most to lose, what's the...
Oh, sorry. The most to lose from new advances in manufacturing. Jason?
I would, yeah.
A specific doesn't come to mind, but a category comes to mind. I think commodity manufacturers are a big one, and I think companies that don't have design as a core competency.
Right.
Yeah, I think the companies that have lost design because they have outsourced the manufacturing and then lost it. One that comes to mind is Dell.
Yeah.
Mark?
So I talked to a CTO at an automotive company who didn't understand the power of open innovation or enabling people outside of their normal and traditional supply chain from innovating, and I think they're hosed.
What type of product will have the highest percentage that are designed by consumers in 5 years? Mark?
Well, clothing's the easy part.
You already mentioned socks.
Yeah. I'd say phones, probably, yeah.
Right.
5 years, certainly 10 years, it's going to be the IKEA, the furniture.
I think autos. I think they're getting much better at configuration, both the software and the actual experience inside of an auto. I think we're gonna have a bespoke auto experience like we do with clothing today over the next 4 to 5 years.
Wow. What will the average salary of a U.S. factory worker be in 5 years?
What is it now?
$52,000.
52?
I think it's total cost in. I'm not sure that's salary.
That's probably total cost.
Yeah.
I would have guessed 50 to 60.
In 5 years, it will be still. Yeah.
Pass.
I think it's got to be higher because they're going to have to do more. I mean, we're, to my surprise, frankly, one of our partners is now the AFL-CIO in Pittsburgh, and they're retraining their folks how to use CNC machines. And they are going to get more money as a direct result.
And the final question, what domestic service other than floor and gutter cleaning will be the most likely to be performed by robots in 5 years? Mark?
I'll pass to the iRobot guy.
Jason?
Boy, I hope it's something menial like dishwashing or something.
Rod?
I'll just put a different angle on this. Automobiles are becoming robots, and that will enable people like me to drive longer as I get older. It'll give me more dignity in my old age because it's safer to drive. I think there's going to be an inversion happen where robotics comes into elder care by empowering people to be independent longer. I don't know exactly what they're going to look like, but there is a demand from people my age wanting to be independent longer, and that's going to pull robotic technology into the elderly's lives.
Damn, that was a good answer.
Thank you very much. Thank you all.
I'd like to thank our speakers for sharing your insights and your passion with us so freely. We really appreciate it. We wish you the very best of success. Michael, you are inimitable in your style. Love the lightning round. Thank you so much for all that you put into the success of this program. For each of you, we have the much coveted Churchill Club speaker t-shirt. Please wear it in good health. Thank you again to our sponsor, Plex Systems. A recording of this program will be available over the next day or so on our YouTube channel. And you have been a terrific audience. Thank you so much. See you next time. Good night.